Hello and welcome to another video. In this video we're going to be continuing on with the zero track list. Haven't done a problem in a while, been kind of busy, but now is some time. So we're going to be doing 3316, find maximum rules from source string. Alright, so here you have a source of size n, string, subsequence of source, int array target indices that contains numbers from 0 to n minus 1. Define operation as removing a character. Okay, pattern is subsequence, performing operation does not change indices. So if you remove C, okay, so you have source, you have pattern. I guess target indices is the ones you're allowed to remove. Let's look at the constraints. 10 cubed. Okay, target indices contains distinct elements. Source and pattern consist only of lower English letters. Pattern is a subsequence of source. Okay, so like sometimes we'll just be able to remove nothing. Okay, you can remove source 0. So if you remove source 0, you can't. Okay, so you can't remove source 0 because then you get this, and that's not a sub. Okay, you can remove source 1 because then you get this. So you can't remove. You move 1 and 2. You can remove 1 or 2. Okay, so it's 1. Here 0, 3. So you can remove both because you just want the D, so you can remove either 0, 1, or 3. Here we can't remove anything. Okay, got it. This one, 0, 2, 3, 4. All right, let's go through this example. I feel like this might be the most meaningful. Let's see. All right. So 0, 2, 3, 4. Okay, so if we remove 0, then we can still make it. So this is fine to remove. 0 can be removed. Okay, interesting. So I think yeah, because we still do have the y. Yeah, we do. Okay, what about 2 now? So 0, 1, 2. Can we remove that? No. Okay. Can remove this. Let's see. Y. Yeah, so how do we remove 3? Did I miss something? Did I write it correctly? Let's double check. Yeah, okay. I think I just copied, yeah, so how would we remove 2, 3? So we'd remove this. Then we get, okay, we still get it. But if we remove this instead, then we can't get it. Because we need a Y and we need an E in between the Y. Sorry, we need 3 Ys. Right? Yeah. So we need 3 Ys, we have 4. So we can remove one of them. So we can either remove this or this. We can't remove both. I don't see why it makes a difference. I guess the order doesn't matter. I guess. Yeah, because yeah, I thought it would just be some greedy thing, but yeah, so here if you remove this, then we don't have like this thing, or we do still, but it's Y, E, Y. Oh, Y, E, Y. Okay. Yeah, so we can remove this, but then we can't remove this because we need 3, and we also can't remove this. Yeah, I see. Okay. Well, I guess it doesn't really matter, right? Like we can just try them all, and then that's whatever. So I think it'll still work. I think we just do a DP of like the index we're at, and that's it. In the source string, let's see, source string is 10 to the 3rd. Pattern is 10 to the 3rd. I think that's fine. So yeah, we're indexing the string, indexing the pattern, and then we just try to remove or not, and that's it. And then at the end, so yeah, so this is going to be that. So this is like state here. We'll be like ij, where we're at, indexing the string, indexing the pattern, base. So out of bounds in source, but not in pattern. We want to make sure this is never used. So we'll just return, we're trying to maximize or something. We'll return like negative infinity, I guess. Yeah, so negative infinity. Okay. Out of bounds in pattern, that means we can just delete everything else from the source. So that's fine. Or actually, out of bounds in pattern. So I think actually out of bounds in pattern. Yeah, out of bounds in pattern, I don't think we want to return. I think we want to keep going until we're out of bounds in source. Yeah, so out of bounds in pattern is fine. We just means, yeah, that's fine. We don't want to early return because we were going to want to delete everything else in source, right? So like, for example, if source is this and pattern is this and we're out of bounds, like we still want to go through and delete everything. So this is not a base case. So it's actually just going to be out of bounds source inf, if not also in pattern, or 0 if also in, or sorry, let's see, operation. So yeah, or 0 if also in pattern. Okay, and then recursive is just, let's see. So what else can we have? Like, what if we can't remove and we don't have a match? Then it doesn't matter because we'll just, it's a subsequence, so that doesn't matter. So it's just like take or not take the letter, and if it's in the target, add to result. If we don't take it, because that counts as a removable. Yeah. So if it is, then whatever. We can just take or not take anyway. Yeah. Okay. Let's go to think. So. So yeah, like ij, or we can call this sp. So if s equals, we can do this. Source. Alright, so if s is s, if p is this one, let's see, yeah, if p is this, then return 0, otherwise return negative infinity. Alright, and then we just do take or not take. If the letter is equal and it's in our, like, let's see. If the letter is equal and we aren't removing it, we're always taking. So let's just do that case. So if, so target indices, we can maintain an index if it's sorted. Yeah, so we can maintain an index or we can just turn it into a set. I'm just going to turn it into a set for simplicity because we're going to have like a bunch of other stuff anyway. So yeah, so we can just say like target indices equals set. So if, let's see, s in target indices, return max, so we remove, which means we go s+1, pattern stays the same, or we keep. Let's actually calculate that separately, actually. So remove car dp, so remove is just this. Keep, if we keep, well actually, yeah, so actually, yeah, I think this is the remove, and then regardless of if it is, if it isn't, we were going to keep. Yeah, so this is going to be the other case, so keep car. So keep car, basically, if it matches, so I guess we'll do another case, so if, let's see, s, oh, okay, so if, so p has to not be out of bounds. If p is out of bounds, what do we want to do? Yeah, so p has to be in bounds, but yeah, so p is less than length p, that we have to actually like be able to keep. Let's see. Okay, so this is the match case. So we'll just go res equals, we're trying to minimize. Yeah, we'll just go this. All right, and then we can do this. Or actually we're trying to, wait, what are we trying to do here? Oh, maximize, yeah. So, all All right. Okay, so this means we can keep the character. So and let's see, source s equals pattern p. Okay, so this means we're just gonna move them both up. So as equals both up. Okay. Otherwise, we can't take the character. So else here. All right. So here we do a removal. So 1 plus. All right. Let's double check. So target. Okay, so if we complete both, there's nothing else we can do. If we didn't complete both, that means it's no solution, so negative infinity. We're trying to maximize, right? Yeah. Result is negative infinity because we're trying to maximize. So if we can remove the character, we'll try it, which means we'll just move the string up and keep the pattern the same. If there's a match, we just always greedy take. And then if there is no match, then we have to skip. So this is just like the normal DP of like, it's a substring and a string or whatever the thing is. That one's pretty straightforward. All right, I think we're good. Let's give it a go. Maybe we're not. P. Oh, right. This is P. Okay. All right. Is that good? Nice. Let's just quickly talk about optimizing. Not going to do it, but okay. So we're always moving 1 in S, so we can have like a few states, like these 3 basically, or not these 3, but yeah, I guess every state in S depends on like this is all S plus 1, S plus 1, S plus 1. So if we just keep track of like this is the same as this. Yeah, so we can definitely like space optimize and get rid of, we can definitely make it like 1D instead of 2D for space. Time would be the same. Let's take a look at a solution. MN, yeah, so you can make it N if you space optimize. Not gonna do that in this case, I think. No, I don't really care. Yeah. And then same kind of thing, because we're doing top down, it's just slower than bottom up, but that's whatever. Fine. I'm mostly just trying to make sure I get these like algorithms correct. The space optimizing and all that is the same everywhere, so that's just like a different thing that I don't want to work on. Yeah, I mean, I did recommend like it is good to do it once in a while, so maybe I'll do it once in a while, but not right now, I guess. Okay, so yeah, this is just be like mn space mn. Right. Yeah, we'll see for the tougher problems. If we get a lot of TLEs, I might just do bottom up as a standard. Like I'm worse at it for sure, but I think there is some merit in learning, and then I'll just space optimize everything. But yeah, we'll see how that goes. Either case, gonna be it for this one. Not too bad. Yeah, I feel like pretty straightforward. It's literally just like as a substring and a string, which is like a really easy DP. Not even DP, it's just greedy. And then there's a small thing. So yeah, maybe not as hard as the thing, but also DPs get harder numbers, so who knows. But yeah, that's gonna be it for this one. Hopefully you liked it. If you did, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.